Okay, last two problems are graphing and finding domain and range. This is important. So, if you want to graph y equals log base b of x, when b is greater than 1, when the base is greater than 1, so, it's kind of, so an example would be like y equals log base 2 of x, or 3, whatever. Anything greater than 1, it's going to look like this, okay? It's going to be an asymptote right here, and it's going to do this right here. So this is going to be closer and closer to the x-axis. Okay. Now, log functions will look like this. So what is this y-axis called then? The y-axis is the asymptote. Okay, y-axis is now the asymptote. Now, this one over here, y log base b of x, when b is less than 1 but greater than, sorry, it's just sloppy, 0. So when b is between 0 and 1, like 1/2 or 1/3, 2/3, like y equals log base 2/3 of x, when that base is less than 1 but greater than 0, it's going to be the opposite of this. Doesn't this remind you of something from before? It's going to be flipped over the x-axis. So it's going to look like this. Okay, see how I flipped over? Take that, this one, flip it over the x-axis, and it looks like this one. This is a rough sketch, but see the idea. Okay, it's like going down this way. This one's kind of starting here and going up. Okay, so this is how you want to graph these two. Why does that help you? What are you getting out of this? We're going to find domain and range of these functions. Okay, now look at this one on the left right here. What is the domain or range? What do you think? What could x be? What couldn't x be? Right? X is your domain. So look at the picture. The picture tells you everything. Okay. It starts down here. It actually keeps going down, right? Closer and closer to this y-axis, keeps going down, and it keeps going up. What is that dealing with? Keeps going up, keeps going down. That's dealing with the y values. So what are the y values? They're all real numbers. Keeps going up, keeps going down. So for this one, the y values, which is your range, is all real numbers. I just tell you this. For logarithms, the range is all real numbers. Look at this one over here. It's going up, and it goes down, 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 down. Forever. Goes up, goes down. So the range over here, same thing, is all real numbers. Now the domain is the harder part. In these cases it isn't that bad, but I'm going to give you a case where it is a little more difficult. Domain, basically, what could x be, right? And look at the picture. Where does it start? X-wise. If you're looking left to right, I mean, it starts right here, right? I mean, it's here, and then go this way. Go to the right. What is this? This is when x is 0, right? X is 0 to the right of that. So basically, your domain is x has to be greater than 0. I just tell you this. After the log, like log base b of this thing right here, that can never be negative, and it can't be 0. Okay? Can't be negative, can't be 0. Watch what I mean. I'm going to give you an example. Log base 2 of, let me put 0 right here. Alright? Well, if I said, hey, what is this answer? What does that mean? Well, how would you try to figure out? 2 to some power is equal to 0. Is 2 to any power equal to 0? No, you can't do that. Right? 2 to some power is not 0. What about a negative? All right, let's do a negative example. Log base 2 of, let's even put negative 2. Look at that. Could you do that? What does that mean? 2 to some power equals negative 2. That's what it means, right? What power would give you a negative 2 over here? No power. Any power you put a positive power here, you put a negative power here, you're always going to get a positive answer. Okay? So that's why when you write this, log base whatever 2b whatever to the x of x, that's why x has to be greater than 0. Okay? Because this can't happen, right? You can't have 0 right here, and you can't have a negative right there. So that's why we say x has to be greater than 0. In this case, that's your domain. But it's going to get a little bit more difficult than that. So, but that's the basics. Alright? So know how to do domain and range of these simple functions, and we're going to find, alright, what about this domain right here on this side? Well, it starts here. X is 0 to the right, so x is greater than 0. But do it algebraically. Just look up here. Whatever's to the right of the log, right here, that thing has to be greater than 0 for domain. Okay? Domain x greater than 0. Isn't this the total opposite of what you did before? Exponential functions. What exponential functions look like? Right? Exponential function. Here's an exponential growth. What was the domain and range of this right here? Domain is everything, all real. Range, well, it starts here and it goes up, right? It's from here up. So y is greater than 0. This is the opposite of what we're doing right now, logarithms. Well, logarithms look like this, right? It's the opposite. So it's the inverse. Okay? I mean, let's put this picture right here. Check this out. Put this picture right here. You understand what's going on here? Let me draw this line. Does this make any sense to you? This is the line y equals x. This is reflected over the line y equals x. That means these two are inverses of each other. That means that they're opposites of each other, which means if the domain is all real for one and this for the other, that means you flip those, and that's the domain and range of this. So domain for this is greater than 0, x is greater than 0, and the range of this, I mean, look at the range, up and down, it goes up, it goes down, so all real. See how they're total opposites, they're inverses of each other? Okay. So that was the easier one, so let's do the harder one. Okay, so let's look at this right here. Log base 3 of x. If you were to do some coordinates, I'll just show you what the book shows you here. You find some coordinates. How? Just plug in a couple numbers for x right here. This is how you would graph. Okay, right now you actually can't type in base 3 in your calculator, so you have to just kind of say, okay, if x was 1, what would this be as an answer? If x was 1, 3 to the 0 would equal 1. There, okay. If x was 3, just put in good numbers like 3, log base 3 of 3. Well, that answer is 1. Then put in 9 because that's easy. Log base 3 of 9, so 3 squared is 9. So there's 3 coordinates right there you can draw on a graph. So you put those on a graph, and here's what it'll look like. Okay? I showed you those go like this. If this base is greater than 1. So what could you tell me if I say what's the domain and range? Domain, let's do range. Range goes up, goes down, range is all real. Okay? What's your domain? Well, look at it. Just look at this. Whatever's right here has to be greater than 0. So that's it. X is greater than 0. If you want to look at the graph, I guess you could tell everything from here to the right. So everything greater than 0. There you go. So that's how you do example 7a. Example 7b, notice the base right here. You should know what that looks like. So off to the side you can draw yourself a little graph. Say, okay, it should look like this. The other one should be this way, which means you flip that, which means it should look something like this. okay, which it's going to. So pick a few values for x and find a little table. Okay, there you go. Pick 1 for x, you'll find 0. Pick 2 for x, you'll find -1, so on and so on. Plot those points here. Get a nice graph. Notice the y-axis is an asymptote. Okay? Alright, now, look at that right there. What is your range? It goes up, it goes down, your range is all real. What is your domain? These are easy right now. What's your domain? It starts here and it goes to the right. Just this right here. So x is greater than 0. If you want to look at this, whatever's here has to be greater than 0. Okay. Example 7 done. Last example, example 8. It's another translation. So we got h's and k's. So log base b of x minus h plus k. Write that down. All it does is it shifts h and k. So, what is h in this case? Well, it's supposed to be x minus h. So, h equals -3. K equals +1. Excuse me. Now, let's graph this. What if it was what if h and k wasn't here? It would be log base 2 of x, right? Let's draw a quick graph. Watch this. Watch how this works. Draw a quick graph of this without h and k. What would that look like? It would look like something like this, right? Rough sketch. What did it move? How did it move? It moved. H is -3. K is 1. H moves it left or right. K moves it up or down. So I'm going to move it left because it's -3. So 1, 2, 3. Look where my new asymptote is. It's right here. The asymptote was this, right? The y-axis. It moved left 3, so there you go. Pay attention to that. So this is the key. The h is the key in this case. The k, I mean, it's going to move it up 1, right? It's going to move all these coordinates move up 1, so they're all, you know, going to be it doesn't really matter. It's just a rough sketch. Okay, that's kind of ugly, but you understand. It moved left 3 was the big idea. And all these coordinates moved up 1. Okay, it kind of looks like that. Alright, but now, what's the key? Why is that important? Because here's the key to the whole thing. Domain or range. What's the domain? What's easier? Range is easier in this case. Domain, range. Pay attention. Range, it goes up. We're looking at this one. It goes up and it goes down. The range is all real. And I'll just tell you that happens for every log graph. The range is all real. Alright, every exponential graph, the domain is all real. That's what you learned last time. Alright, what's your domain in this case? Look at this. Your domain, if you look at the picture, it starts here and it goes to the right, right? Notice where it's at right here? Okay? But actually the way you probably should do it is whatever's after the log has to be, I told you this before, has to be greater than 0. So whatever's after the log, which is x plus 3, the log of something, after log, x plus 3, has to be greater than 0. Just solve this and you're done. Minus 3, minus 3. X has to be greater than -3. That's your domain. X is greater than -3. I taught you how to do that for the exponential functions as well. Okay? There you go. So x is greater than -3. What do you do for domain? You look at this right here. Whatever's after the log, you make it greater than 0. That's the key. Understand how to find domain for all these logarithm graphs. Okay? There you go. That's section 7.4. Took a while, but we're done. Alright? Look it over.